Okay, this is lesson 2, graphs of linear functions and rate of change. So functions left are number 1 and number 2 have tables shown below. Find the rate of change for each function and examine each of them. Make a conjecture about which will be linear and justify your claim. First of all, remember the output is the rise and the input is the run. So if I check these, this should be going up by 2, and this is going up by 2. This is going up by 1. This is going up by 1. This is going up by 3. This is going up by 3. So these all are going up by 1. This is going up by 4. And again, this is the rise over the run. This is going up by 1. This is going up by 5. This is going up by 1. This is going up by 3. This is going up by 1. So if you notice, these are not going up by the same thing. So function 1 would be linear because it has a constant rate of change function 2 does not. Now let's prove that by doing our m equals formula. So when we do that, here we have m equals, well, first of all, let's get our points. So we have 2 comma 5 and 4 comma 7. So we have m equals y2 minus y1 over x2 minus x1. So we have 7 minus 5 over 4 minus 2, which equals 2 over 2, which equals 1. Our next set of points would be 4 comma 7 and 5 comma 8. So m equals so we have 8 minus 7 over 5 minus 4, which equals 1 over 1, which equals 1. Our last one, we have 5 comma 8 and 8 comma 11. So m equals y2 minus y1 over x2 minus x1. So for that one, we also have 11 minus 8 over 8 minus 5, which equals 3 over 3, which equals 1. So all of these have the same rate of change. So here we have 0 comma negative 3 and 1 comma 1. So here we have we have 1 minus negative 3 over 1 minus 0. So we have 4 over 1, which equals 4. Next, we have 1 comma 1 and 2 comma 6. So we have m equals y2 minus y1 over x2 minus x1. So here you can already tell that these are not the same. Therefore, they are not linear functions. So next. Let's take a closer and further closer example. Look at function 1, which assigns the inputs and corresponding outputs shown in the table below. It says, why is function 1 a linear function? And check at least 3 pairs of inputs and their corresponding outputs. Well, here it's because it has a constant rate of change. And again, we show that by our points. And notice I'm using the same first point, which is okay. I mean, we don't have to, but we can. It doesn't matter which points we use, as long as we are using 3 different points. So therefore, they are working here. But notice no matter which points we use, we are all still getting that same constant of rate of change. Okay? So now it says what equation, okay, describes the function. In other words, we need to find the y-intercept. Okay? So here we have y equals mx plus b. And we can use one of the points. I'm going to use 2 comma 5. So we put in 5. And this, our slope is that 1. And times 2 plus b. So 5 equals 2 plus b. We are going to solve for b. So subtract 2 from both sides. And we get b equals 3. So therefore our equation is y equals x plus 3. It says, what will the graph of the function look like? A line, because there is a constant rate of change. Okay. So next, let's look at our second function there. Okay, let's look at our second function. So this function, it's not necessarily a straight line. When we checked here, we had negative 2 comma 4 and 3, 9. So when we checked here, we had 9 minus 4 and 3 minus negative 2. And for here, would equal 5 over 5. Well, that equals 1. And here, we can use negative 2, comma 4, and 5, and 25. Here we can say 25 minus 4 and 5 minus negative 2, and we get 21 over 7. And that equals 3. Well, these don't match. Okay, so it says, what do you notice about this rate of change? Well, the rate of change is not constant. So if there were a linear function, what would we expect to see? A constant rate of change. Right? So we have enough evidence to conclude that this function is nonlinear, since I spell it right. Okay. Would the graph of this function be a line? No. And because it does not have a constant rate of change. And therefore, you cannot write in y equals mx plus b form. So next, we have a couple of quick examples. The first being to see if this is linear or nonlinear. Well, to check that out, we've got to do the work. So we have 2 comma 5 and 3.58. So we have y2, x2, y1, x1. So here we have m equals 8 minus 5 over 3.5 minus 2. So we have 3 over 1.5, which equals 2. Or 1.5, actually. So next we have 3.5 and 8 and 4 comma 9. So here we have 9 minus 8 over 4 minus 3.5. So we have 1 over 0.5. And last we have 4 and 9 and 4.5 and 10. So we have m equals 10 minus 9 over 4.5 minus 4. So 1 over 0.5. Let me get my calculator. Nice. We have this is 2. So then we have 1 divided by 0.5, which is 2. And this is also 2. So then that we now have to find our equation. So we have a linear equation, or a linear function. So we have y equals mx plus b. So let's put in 2 and 5. So we've got 5 equals 2 times 2 plus b. So 5 equals 4 plus b. So subtract 4 from both sides. So b equals 1. So our equation equals y equals 2x plus 1. So next, we're going to check. We have -3, -25, 2 and 10. Let's fix these here. So now we have 10 minus -25 and 2 minus -3. So we have 35 over 5, which is 7. Our next one we have 2 and 10 and 5 and 31. So let's check that one out. Okay. And we have 5 and 31, 8 and 54. And that makes this nonlinear. So therefore, we don't have to do any of that because these do not match. So our last one, let's check that one out. We have -2 and 3 and 8 and -2. And then our last one. Let me move this up just a little bit more. There we go. Okay, therefore this is linear because they all simplify to -1/2. So now we have y equals -1/2 x plus b. So why don't we use the -2 and 3? So we have 3 here, and we have -2 here, so plus b. So we have 3 equals 1 plus b. So subtracting 1 from both sides, we have b equals 2. So our equation equals -1/2 x plus 2. And then that ends our lesson for today.